Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 9, Lesson 2, Solving Quadratic Equations by Factoring. After this lesson, you'll be able to have another method to solving a quadratic equation. In the previous lesson, we used graphing or looking at tables to find the solutions or where the x-intercepts were. And I did show you, I gave you a hint about factoring in the previous video. So like we did in Topic 7, we practiced factoring trinomials. We're going to use that as a method to solve quadratic equations. In the model to discuss, we have an artist making a mosaic using tiles to cover this wall. You can see the wall is outlined in the gray with a distance of x longer and wider than the mosaic. And the mosaic is 4 by 6. So can we write an expression to represent the total length of the wall and the total width of the wall? Well, yes, we can. The length is going to be 6 plus this x right here, and the width is going to be 4 plus this x there. So there's the expressions for the length and the width, and we could then multiply those two dimensions to get the area of the whole wall. Okay, and we know how to do this. Multiply using the FOIL method, or you can use an area model. X times x is x squared. X times 6 is 6x plus 4x plus 24. So our expression would be x squared plus 10x plus 24 to represent the total area of the wall. How can we determine the area of the part of the wall that the artist has not yet covered? Well, this expression is the total. They've already covered 24. We just need to subtract 24, which cancels that constant out, and what is left is what still needs to be covered. So x squared plus 10x still needs to be covered. So how does factoring help us solve quadratic equations? Well, when we're solving quadratic equations, remember we're looking for where the equation is equal to 0. That's where the function crosses the x-axis, where the x-intercepts are. And because of the zero product property, whenever I have something times something and the product is 0, then I know one of those things, one of those factors has to equal 0. Either A equals 0 or B has to equal 0, because 0 times anything will equal 0. So one of those factors needs to equal 0. That's what we're going to use. So we have these two binomials, x minus 9 and 5x plus 2. If it's set equal to 0, then I know each piece can equal 0. So I'm just going to split apart the two factors, and then I have two separate expressions equal to 0, two separate equations. X minus 9 can equal 0, or the other factor, 5x plus 2, can equal 0. And then it's easy to solve for x. We just do the opposite operation. So add 9 to both sides, and x can equal 9. Or we would subtract 2 and then divide by 5, and x could equal negative 2/5. So the zero product property is very useful if we have factored form. So if we have already broken up into our two binomials and it's equal to 0, then set each binomial equal to 0 and then solve for x. If we double check, we can plug that in. So plug in x equals 9 into the whole equation. Plug it in. So 9 minus 9 equals 0. 5 times 9 is 45, plus 2 is 47. 0 times 47 does equal 0. That works out. Then we can substitute the other solution, negative 2/5. So negative 2/5 minus 9. 5 times negative 2/5, that equals negative 2, plus 2, that will equal 0. And then so we'll have negative 9 and 2/5 times 0. Of course, anything times 0 equals 0. So let's use the zero product property to solve these equations. They're already factored. We already have our two binomials. So I'm just going to split the binomials and set each factor or each binomial equal to 0. And then x plus 3 equals 0, and then solve for x. Add 1 to both sides. 2x equals 1, divide by 2, x equals 1/2. There's one solution. The next one's easy. X will equal negative 3. So my two solutions for the first equation is 1/2 and -3. So remember, that means those are the x-intercepts. That is where the graph of the function would cross through the x-axis. Let's do b down here. I'm going to split apart the two binomials and set each factor equal to 0 and then solve for x. Because of the zero product property, something times 0 will equal 0. Subtract 3, 2x equals -3. Divide by 2, x equals -3/2. There's one solution. Add 1, 3x equals 1, x equals 1/3. So there are our solutions for part B. Those are the x-intercepts. Example 2, solve by factoring. So if you start with a quadratic equation in standard form or it's not yet factored, just think back to our factoring rules, how we factored it into two binomials. We always want to take our quadratic equation and get it in two binomials or two products, two parentheses that we can then use the zero product property, set equal to 0. So we have this equation here, x squared plus 9x equals -20. We want it to be equal to 0. Remember, standard form is ax squared plus bx plus c, and if it's a quadratic equation, we're looking for when it equals 0. So how do we get this equation to equal 0? Well, we just have to move the constant to the other side. So if I move -20 to the other side, it becomes +20, and now we can factor. Now we're going to factor x squared plus 9x plus 20. So remember, look at the constant. What are factors of 20? That will also add up to 9. That's what we're looking for. 1 plus 20 gives us 21. 2 and 10 give us a sum of 12. 4 and 5 will give us a sum of 9. There's our factor pair. And then that's what goes inside our two binomials, x plus 4 and x plus 5. You can double check by distributing. X times x gives me x squared. X times 5 gives me 5x. 4 times x gives me 4x, 5x's plus 4x's is 9x, and 4 times 5 gives me 20. So you can check quickly that you factored it correctly. Once you have your two factors, your two binomials, you split them apart. Because it's equal to 0, we can use the zero product property, set each factor equal to 0, and then solve for x using your opposite operations. So our solutions for this equation, x equals 4 or x equals -5. And you will write it like this. You can write it with and in the middle. So let's factor now to find the solutions to these quadratic equations. Remember, it needs to be in standard form with a constant on the left and the whole thing equal to 0. So in part A, it's already in standard form. I'm noticing I have a perfect square trinomial. So what's the way to factor perfect square trinomial? It's going to be a binomial squared, and it's going to be just take the square root of the constant. So x plus 8 squared should give me that trinomial. And if that whole thing equals 0, well, I can take the square root of both sides. Take the square root of 0, it still gives me 0. So x equals -8. That one was easy because the two factors were the same thing. Okay, let's do part B. Now I need to move the constant first before I do anything. So I need to move the constant to the other side and rewrite it. So x squared minus 12x minus 64 equals 0. Now I can factor this trinomial. So we're going to set up our two binomials. Don't forget to always set it equal to 0. Each step you do, make sure you complete the equation and always have it set equal to 0. Don't lose that. Okay, I'm going to factor x and x. What factors of -64 would add to give me -12? So factors of 64, 36 and 2. I don't think I can get 12 out of there. 16 and 4, I can get 12 out of there, but I need to get -12. So that means my 16 should be negative. So minus 16 plus 4, let's double check. Distribute in your head. X times x is x squared. -16 times 4 would give me -64. Okay, those are good. 4 times x is positive 4x minus 16x. Yes, that gives me -12. Okay, now we have it factored. Because of the zero product property, we can split apart the two binomials and set each factor or each binomial equal to 0 and then solve for x. So x is going to equal positive 16, or x can equal negative 4. Example 3, our application problem. How did we use this in the real world? Well, we have a museum vault with an outer steel wall with a uniform width of x. So the steel is x feet wide all the way around. This side is x also. The area of the museum vault ceiling and the outer steel wall is 1,664 feet squared. So just this area and the outer wall. So this whole thing and this whole thing has an area of 1,664. What is the width of the outer steel wall? So we need to figure this out. We need to figure out this length and this length. So we know the inside of the vault is 20, but then I have an x over here and another x width over there. So I have 2 x's plus 20 is the width. And for the length, again, I've got an x length here and another x length on the other side. So I'm going to have 40 plus 2x for my total length. And then the total area is 1,664. So there are 2 factors, but it's not in standard form. And we have a constant on the right. It's not equal to 0. So we can't solve our quadratic equation yet. We need to turn it into standard form. So let's distribute first our 2 binomials. So we're going to multiply our 2 binomials first. 2x times 2x is 4x squared. 2x's times 40 is 80x's. And then 20 times 2 is 40. So 80 plus 40 is 120x's. 20 plus 40 is 800. How do we get negative 864? Well, we have to move this constant to the left also. So we have to subtract 1,664. And we do that, we get negative 864. Now we have a trinomial set equal to 0. We have a quadratic equation set equal to 0. Now we can factor. So an easy way to do it, if your leading coefficient is a factor of all the other terms, you can simplify it by dividing everything by that leading coefficient. So dividing everything by 4 makes it look a little bit better. So then we get x squared, 120 divided by 4 is 30x's, 864 divided by 4 is negative 216. Now this is a little bit easier to factor. So set up your 2 binomials and factors of negative 216 that also add up to 30. Well, the factors would be negative 6 and 36. Then what do? Now we have it factored. It's set equal to 0. We use the 0 product property. We split the binomials. I'm going to write them over here. We split the binomials and set them equal to 0 because of the 0 product property. So x will equal 6 or x will equal negative 36. So those are 2 solutions. But this is a real world situation. What is x representing? It's distance, it's length, right? It's a unit of measurement. Can we have a negative unit of measurement? We cannot. So this solution is not viable. It doesn't work in our real world situation. So we know now x equals 6. So the width of our steel door, our steel wall, is 6 feet. We can double check by plugging that into our factored area where we had 2x plus 20 times 2x plus 40. You remember the length times the width, and that would equal the total area. So we could just substitute, and if both sides are equal, then we know it's a solution. So yes, 32 times 52 does give us 1,664. Try it number 3. A picture inside a frame has an area of 375. That's why it's written in the middle. Just the picture is 375 square centimeters. We want to know the width of the frame. Well, we can see we know the length and the width of the frame, but we have to look at taking away the area of the picture. So how can we write an expression for this length and this width? Because we know that's going to be equal to 375. We know the width of the picture times the length of the picture would equal 375. So let's write an expression for the width of the picture. I don't know what it is. It's not 20. 20 is the length of the whole picture frame. So we know it's 20, but then we have to take out the width on each side. So how many x's? We have an x on this side, we have an x on this side. So we need to subtract 2x from both sides to get the total width of the picture. The length of the picture, well, 30 centimeters is the length of the whole frame, and we have to subtract 2 x's, 1 x from each side for the width of the frame, and then what that would be the length of the picture. So there's our two expressions, and they're going to be equal to 375, which is the area of the picture. Okay, so now we're not in standard form. We don't have a quadratic equation equal to 0, so we need to distribute first and then move the 375 to the other side. So we're going to distribute. So 200 times 300 is 600. Then I've got negative 40x and negative 60x. And I'm going to have positive 4x squared equals 375. Let's turn it into standard form. 4x squared minus 100x plus 600 equals 375. Subtract 375 from each side, and we would get 225 equals 0. Now we have a quadratic equation set equal to 0. We can use factoring. It looks like it might be a perfect square trinomial, but if we do 15 plus 15 times 2, it's not going to give us 100. So let's factor it a different way. We can't factor it using our perfect square trinomial rule because we won't get that middle term. So factor 4x squared, that would be a 2x and a 2x. Okay, now factors of 225, if I multiply by 2, they'll give me a sum of negative 100. So I know both of these need to be negative. And let's think, factors of 225. Well, 15 and 15, but I don't think that will work because we won't get a sum of 100. So then let's try 5 and 45. I'm helping you out a little bit. This part might take a little trial and error as you're trying to figure out how to factor this, but let's look at 5 and 45. Negative 5 times negative 45 would give me positive 225. Now, if I multiply that by 2, so let's check our linear terms. Let's check the outer and the inner. 2x times negative 45, that would give me negative 90x. Negative 5 times 2x would give me negative 10x. Does that give me negative 100x? Yes, it would. So there are our factors. Since we have factored it correctly and it's set equal to 0, we use the zero product property. Split the binomials, set each binomial equal to 0, and then solve for x. Okay, add 5 to both sides, and then divide by 2, so x equals 5 over 2. Add 45 to both sides, and then divide by 2, x equals 45 over 2. Okay, so 2.5 or 22.5. Those are our solutions. Which one do you think makes sense? Do you think the width is going to be 22.5, bigger than the width of the whole frame? Probably not. So this solution does not make sense for our real world situation. So we know the width of the frame is going to be 2.5 centimeters. Example 4, using factored form to graph a quadratic function. Okay. So remember, once we factor, we have two binomials set equal to 0. So here's our function, x squared minus 2x minus 8. Since it's written as a function, that cues our brain to be thinking about what does the graph look like. Okay, so we can factor that and set it equal to 0, because when we are graphing a quadratic function, we're looking for where they cross the x-axis. So take your function, set it equal to 0, and then use zero product property, split the binomials, set each binomial equal to 0. You find the solutions, or the zeros. You have found the x-intercepts. So plug those x-intercepts, and now think about the symmetry of our parabola. The x-intercepts should be equidistant from the line of symmetry. So you can figure out the distance between the 2 points, the two x-intercepts, find the distance between them, and then divide it by 2. So if I start at -2 to get to +4, that's a difference of 6, right? So the total distance is 6. If I cut that in half, that means each x-intercept should be 3 units away from the line of symmetry. So what's 3 units away from 4? 1, 2, 3, right here. So that's one way to do it. Or you can just find the average of the two x-intercepts. So add the two values together and divide by 2. So there's 2 different ways, but you're looking for the halfway point between the two x-intercepts. That's where your line of symmetry is. Now we know the line of symmetry. We know the x-coordinate for our vertex. So we just need to plug that into our function. So we know x is equal to 1. Plug, you're finding f of 1. So plug in 1 into your original quadratic equation. 1 squared minus 2 times 1 minus 8. You'll get the output of negative 9. So there's your vertex at 1, negative 9. And once you've got your vertex, you have enough points to draw your parabola shape with the curved shape and the arrows on the end. So again, first find the x-intercepts by using the zero product property, factor it, split your binomials, then find the midpoint between those two x-intercepts. That's where your x value for your vertex is, because that will lie on the axis of symmetry. And then plug that into your function to find the output, or the y value for that vertex. Let's try it. Here is our function, 2x squared plus 5x minus 3. Let's factor it first to find the zeros or the x-intercept. So we're going to factor it. We're going to set it equal to 0. Okay, so 2x times x will give me 2x squared. And I need to do factors of negative 3 that will also add up to 5. One of those factors is multiplied by 2. So what if I put a 3 here and a 1 here? I'd have 6 and a 1. Somehow I can combine 6 x's and 1 x to give me 5. Means my 1 needs to be negative, my 3 can be positive. So double check. With your FOIL, check the outer and the inner. 2x times 3 is 6x, and the inner would be minus 1x. That gives me a total of 5x. That's what I want. So I know I factored it correctly. Now I can split the two binomials using the zero product property and then solve for x. So 2x minus 1 equals 0. X plus 3 equals 0. Add 1 to both sides. 2x equals 1. X is going to equal 1/2. Or x will equal negative 3. So there are my x-intercepts. So now we can graph our two x-intercepts. They're at 1/2 and negative 3. I'm going to count by ones. 2, 3. So at positive 1/2 and at 1, 2, 3, negative 3. There's my two x-intercepts. Find the halfway point between those. So this is a distance of 1, 2, 3.5. What's halfway between 3.5? 1.75. So then 1.75 away. So here's 1. There's a half. 1.75 is going to be like right around there. Okay, I'll show you the other way. Just plug in find the average. So negative 3 plus positive 1/2 divide by 2. So that's negative 2.5 divided by 2 gives you negative 1.25. So it should be at negative 1.25, which it is. It's halfway in between negative 1 and negative 1.5. So our x-coordinate, our axis of symmetry, is going to be at negative 1.25. So that's the x-coordinate of our vertex. We need to find the y-coordinate. How do we do that? Well, we plug in x into our function rule. So we're going to evaluate f of negative 1.25. That's our input. Plug that into your function rule. 2 times negative 1.25 squared plus 5 times negative 1.25 minus 3. 2 times negative 1.25 squared. So if we do all these calculations, we get 3.125 minus 6.25 minus 3. Add these together, we get an output of negative 6.125. There's our y-coordinate for our vertex. Okay, so we're at negative 1.25, comma, negative 2, 4, 6, sorry, 1, 2, 3, 4, 5. I'm not quite going to make it, so it's going to be somewhere down here. Our vertex, and we can connect our points with a nice curved shape and arrows on the end. It is going to be upward facing because our A value, our A coordinate is positive, so it should be upward facing. Example 5, write the factored form of a quadratic function. How can you write the factored form from the quadratic function related to a graph? So now we're going to move backwards. We're given the graph. What information does that tell us? Well, looking at the graph, we can see the x-intercepts and the vertex. And now we just need to work backwards to get to the equation. So I know if it's set up in factored form, I'm going to have two binomials equal to 0. And how do I get x equals -5? That means x plus something equals 0. And then if I do opposite operations, it would give me -5. That means I'm adding 5. X plus 5 would give me 0. That means x equals -5. So in this binomial, we're going to have x plus 5. And then for the other one, I had x equals 1. So x plus something equals 0. And if I do opposite operations, I get x equals 1. That means I'm subtracting 1. -1 plus 1, or 1 minus 1 would give me 0. So here's my next binomial, x minus 1. I'm just working backwards. We're doing the zero product property in reverse to get to our two binomials. So there's our two binomials. But how did we get the vertex? What does this information tell us? Well, we can use this as an x value and an f of x value and plug that in to solve for a, because there could be some coefficient out there that we would have in our equation. So if I plug in these values, now I know my output is going to be -9. Let's write it like this. A times, I'm going to say x is -2, -2 plus 5, and -2 minus 1 equals whatever my output is. My output isn't 0 anymore. My output's going to be -9. I'm trying to solve for this to see if there's a coefficient besides 1. So now we're just going to solve for a. So a times -2 plus 5 is 3. -2 minus 1 is -3. It's going to equal -9. Well, a times -9 equals -9. Divide both sides by -9. A equals 1. So there isn't going to be a coefficient in front of my x squared term, my quadratic term. It's just going to equal 1. So we can write the equation. It's just going to be x plus 5 times x minus 1 equals 0. Let's distribute our two binomials. X times x gives me x squared. X times -1 gives me minus x. 5 times x gives me positive 5x. 5 times -1 is -5 equals 0. And combine our like terms. Plus 4x minus 5 equals 0. If you wanted to move the 5 to the other side, you could. So here's our graph. Try it number 5. Let's write the factored form of the function. First, we need to identify the x-intercepts, or the zeros. X is at +3 and x is at +9. So then do the zero product property in reverse. So I'm going to have my two binomials set equal to 0. One of them has to be x minus 3, so that when I do the opposite operation, I get a solution of +3. And then the other has to be x minus 9, because 9 minus 9 would give me 0. I'm looking to see if there is a coefficient or a greatest common factor. So now let's use our vertex as our x comma y. So what is the vertex? The vertex is at 6, -9. There's our x and our y. So we're going to say when our x, or our input, is 6, substitute our x value in the equation, and our output, it's not going to be 0 anymore, it's going to be -9. And now we're just solving for a. A times 3 times -3 equals -9. Well, we're back at a equals 1. So we already have it. We don't have to write our factored form. We're just going to have f of x equals these two binomials, x minus 3 and x minus 9. Because when it is equal to 0, we will have our x-intercepts at 3 and positive 9. Made it to the concept summary for solving quadratic equations by factoring. You're going to want to know the zero product property very well. This is very useful. Remember, though, you have to have it set equal to 0. So sometimes you'll need to move the constant to the other side first as a first step, like you did here. Move the constant over first. Then you factor. Then you split each binomial and set each binomial equal to 0 and solve for x, and you'll have your solutions. Those are your x-intercepts. You can graph those x-intercepts, and then remember, find the halfway point, find the midpoint. There's your vertex. That will give you your x-coordinate for your vertex. You plug that in, you evaluate that point to get the output, or the y value for your vertex. If you have any questions, leave them in the comments. Make sure to like and subscribe, and come back for lesson 9.